Here we go talking about story problems and math tools, the frame. Okay, so these are the things we're going to be having to deal with all year. So it's good that you understand this. So if you missed class or didn't quite get it all, this is a way that you can get that extra information. Okay, so the first part we're going to start with is the frame right here. Okay, talking a little bit about story problems first, because that's how we're going to start a lot of this new learning and information we have, is by looking at a story problem and using that as a jumping off point. So if we look at this, whoops, let's zoom it in, there we go. Okay, story problems and math tools, that's our topic. So this first page is how to figure out the info in a story problem and show it using math tools. Okay, so here's our story problem. Horatio, Johann, and Elena, triplets, actually quadruplets, but Fatima is not into their stupid game. She prefers reading books. We're in need of some money to support their gaming habits. They have already spent $10 on purchasing gems, but they ran out. The three siblings get jobs sweeping the hallways of an elementary school after hours. With their earnings, they each decide to spend $7 a week purchasing gems. How long until their parents decide that they are spending their money on worthless electronic gems just to get further, quicker in a meaningless game? Okay, so that question right there, that's kind of subjective to a parent. So we're not really going to answer the question. We're just going to use the story problem to get thinking. Now, another term you may hear instead is contextual. That basically just means what's the outside, what's the surrounding information with this. So when we're talking about a story problem, the best way to get into it is this. Okay, and this year in Math 1, we're going to be primarily dealing with two groups. Okay, there are a lot of problems out there that deal with more than that, but for us, we're focusing on just two groups. So what we need to think about whenever we look at a story problem is, what are the two groups? What are the two variables? What are the unknowns? Okay, that's another word we could call them. What's kind of connected here? Okay, and once we identify those two groups, we can then say, well, what information has to do with them according to our story problem? And further, so what information is pertinent, is relevant? What relationship pattern do we see? Okay, those are the next two questions once we find those groups. So if we're looking at this story problem, we've got people, we've got money, we've got the gems that they need for their game. Okay. We also have time, weeks, right? So we've got their game, we've got the people, we've got money, we've got time, okay, we've got the gems. So what two groups do we think we're talking about? Okay, that's the tough part, trying to figure that out. Okay, usually the question can help you decide. So if we look at this question, how long until their parents decide they're spending their money? Okay, so that's kind of the key right there, how long and their money. So what we're dealing with here is time in weeks, because that's a connection there, and money, how much they've spent. They've already spent $10, okay, and they plan on spending more each week. So once we got those two groups, then we look for that relationship. Well, we know that they are able to spend more money after they earn some every week. Okay, so there's a relationship. Okay, that's $7 per week. That's kind of that pattern, that relationship right there. Okay, so next we look at, well, where does the pattern start? Okay, we want to know where things are starting. So we're talking about how much money they'll spend or are spending, and we should see that they've already spent $10. That's the start. Okay, they've spent that $10. Now, what's the pattern? Okay, how's the pattern going? Well, every week they each are going to spend $7. So $7 each week for each one, or if we're thinking all three, because it sounds like all three of them are involved, they each spend $7 a week. So that's 7 plus 7 plus 7, or 7 times 3, or 21. So $21 a week is what they'll be able to spend. Okay, so once you have that starting and that pattern, that's when you will be able to use some of these tools. Now, the thing with these essential math tools, okay, we could also use the word methods or models, okay? Those are words that work as well. Model is probably the most mathematical one, and the one that if you went to someone and said, like a professor at a college that teaches math or deals with math, you'd probably want to call them models. Okay, the first is a diagram or a picture. That's a really great way to start a lot of problems, and sometimes that can help you if you don't even know what's going on yet. Is trying to draw it out and see what's happening according to the story. Okay, it also helps you identify what information you may need and what you already have. A table is a great way to start because it shows you where we start. It shows you kind of how the pattern is growing, and it helps you identify numbers that aren't in the story problem. That's what makes a table great. A graph is a good visual. It's kind of similar to a table. It connects the two pieces of information, the two groups, and it does it in a very visual line, something that we can look at and kind of understand very quickly in certain aspects. The last tool we're talking about, so diagrams, table, graph, and finally an equation. An equation helps us model what's going on that we can then use for other purposes. And this year we're going to talk about two different types, recursive and explicit. They're two different types of equations. Okay, now each one of these tools, once we find one, it's usually easy to go in between them, from like table to graph to equation. The diagram sometimes is tougher to mix around, but each one of these is useful and has its own abilities kind of idea. So depending on what I want to do with my results, one of these models can help me do that better. Okay? So, why that last box on the bottom? Why is it important to understand and manipulate different models when dealing with story problems? Okay, well, each tool or model highlights different aspects of a problem. They help you show the groups involved and the relationship between them. It helps you see the patterns in different ways, and helps you understand the contextual information better through the different models. Okay, so these models aren't the result, they're not the end, they're the means to the end. Because when you're dealing with a story problem, you want to be able to answer this question. And think about this question. If you're a parent, which one of those models, a graph, a picture, a table, an equation, which one of those is going to show how much money your kids are spending easier? Okay, probably a table or a graph. Okay, if you're the child and you want to show your parents but you don't want them to stop you from doing it, something that hides the information might be better. So it depends on what your result is and what you want to get out of it, which will determine which one you want to do. Alright, so there's the first page. Now the second page is more getting to the nuts and the bolts of how we switch between some of them. Okay, so switching math tools, part 1. This is how to make tables from story problems, graphs, and equations. So let's focus first on the story problem to a table. So that's this area right here. Okay, so and we're using that story problem for this one that we had on the other side. So to figure out how to get it into a table we usually make with 2 columns. Okay, those stand for the 2 groups. Then below it is the information. We usually start with the beginning, where they start, and then document how they change. So that first step here, decide which are the 2 groups and put them over the 2 columns. So in ours we determined it was weeks and money spent. Now I could put weeks over here and money spent over here, that doesn't matter. Typically time ends up on the left, but it doesn't have to be that way. Okay, so we got the 2 groups. So then the second part is determining, okay, where do they start? Okay, what happened at the very first? Well, the very first when we met them, they had already spent $10. That was before they got a job, so before the weeks were changing where they earned more money. So we start at 0 and 10. That's where we start. Okay? Then that last step is to look at the relationship and write down the pattern one step at a time. So the pattern was they each earn money every week, and they're each spending $7, and there's 3 of them. So every week we're going to see how much more they've spent. Okay, and we're going to add $21 to that each week, and you can see the pattern of money spent. So within 6 weeks, they've spent $136. Okay, as a parent, see how useful this model would be? Because they say, probably hopefully somewhere around here, week 1, they're like, what are you guys doing? Why are you spending your money on that crap? Okay, this is very easy to see, very plain, how much is the kids are spending. But that's how we go from a story problem to a table. Okay, now let's talk about going from a graph to a table. These ones are pretty simple. So a graph is just that line. You want to plot the points on this line. Now, yes, there are points everywhere on these lines, but they're not always easy numbers and useful. So what you think about is you look at those intersections, right? 1, 2, 3, -1, -2, that you can find points and get their coordinates, like -2, 3. That's an easy one to get, right there in the middle. If I tried to get one halfway in between, that would be tougher. Okay? So that's what you want to do. You want to find those points like I've already put on this graph. Okay? So then what you do is you write the points as coordinate planes. So we've got our ordered pairs here, okay, on this coordinate plane. Remember, when we write an ordered pair on the coordinate plane is just that grid. An ordered pair is the numbers. It's always the x value first and then the y value. And they correspond with the x-axis and the y-axis. Okay? So you can make a table. Now this table I made was a horizontal one. You can do it vertically. No reason we couldn't go like this and go x, y, and fill out our information like that. I was just doing a horizontal because I needed to save the space and because just to show an opposite. So, because we're usually on a graph dealing with x and y, label your columns x and y, or your rows. Then, for each ordered pair, the x value goes in the x row or column, the y value in the y. So if I was doing this one, it would be 0, -4. And then just go through all of them. 1, -1, 2, 2, 3, 5. Now, I do want to usually go in some sort of order on one of the sides. Okay? Because then I can see the pattern and I could keep going with 4 and 5, figure out how this is growing, and put my information in there. But when you're given a line, that's how easy it is to go to a table. Okay, next up, we're going from an equation to a table. Okay, this is probably the toughest one. So we've got an equation here. We've got our 2 variables. So just kind of with the graph, we label them. X and Y, X and Y. Okay. Then we're going to pick some numbers for one variable. I usually like to do X, but it doesn't matter. You can choose Y. So I pick one variable, I'm going to pick X, and then I choose some numbers. Now, make it easy on yourself. Pick small numbers and make it a pattern. Notice how I'm adding 1 each time on this left column. If you make it a pattern, it's going to make your life a lot easier, because if you have a pattern, focus on 3 of your numbers. Okay? Then what you're going to do is you're going to take those 3 numbers that we had, those first 3, -2, -1, and 0, and we're going to substitute them in for the variable that we chose. We chose X, so I substituted in for X. Then we solve the problem. And so 2 times -2 is -4. I need to get Y by itself, so I add a positive 4 to both sides, because that'll undo those ones. Then I'm left with 4y equals 14. I divide by 4. Y equals 14 divided by 4, which if we reduce is 7/2, or if you use a calculator or change it to a decimal, it's 3.5. Okay, then we do the same thing for -1. Follow the same process, and we get y equals 3. Do the same thing for 0, gets y equals 2.5. Okay, so then we take those numbers, those corresponding numbers, and we put them in the remaining variable. So at -2, we found out y was 3.5. At -1 for x, we found out y was 3. At 0, we found out y was 2.5. Then a pattern should emerge. Because we made a pattern of adding 1 on this left side, on the x, if I follow the numbers down here, I notice that I'm subtracting 0.5. 3.5 to 3, we subtracted 0.5. If we subtract 0.5 from 3, we get 2.5. So that's our pattern. So then I can fill out the remaining numbers based off of that pattern instead of plugging them in. And if I'm not sure if I have the right pattern, pick your last set of numbers and go check them. Okay, right there. I plugged in the 4 because we had 4 and 0.5. I solve through it, and yeah, get my answer is 0.5. So we were done. So that's a tough one because you need to be able to manipulate those equations and understand how to solve them. But there we go. That's the different ways from a story problem, a graph, an equation to put it into a table. And a table is really easy to use to figure out other information. So let's take a look at this last page. Now, I made a few mistakes on this, so sorry about the having to cross out some things, but I wasn't going to write the whole thing over. So, how to figure out the method for going from equations and tables to graphs. Okay, so we're just focusing on equation to graph. I didn't do a story problem to a graph because I think it's easier to go from a story problem to a table and then from a table to a graph, because look how easy it is. You can go from a story problem to a graph, and it's basically kind of the same process as the table. So label the two columns on the graph and make points from the numbers. Okay, so we have our table, we've got our variables. If those were like weeks and money spent, you could just label your axes weeks and money spent. Okay, it would work the same way. But typically we see x and y, and x is usually horizontal, y is usually vertical. You could change that. Okay, then those points, the x value and the y value with each other, they make a point. They make that ordered pair. So you just transfer all of these over into ordered pairs, then you plot them. Okay, plot all those points. Once you've plotted those points, you connect the dots and you draw it. Typically you need at least 3 points to draw the line. But that's all there is from going to a table to a graph, so it's fairly easy to do that one. Now let's talk about going from an equation to a graph. And we'll start out with slope-intercept form. Slope-intercept form is often called y equals mx plus b. Now the m stands for slope, and the b stands for the y-intercept. Think of the y-intercept as where we start. Think of the slope as what the pattern is and where we go. Just like on a table, that's probably the easiest way to go from a story problem to a graph, is to say, where's my start? That's my y-intercept. What's my growth? What's my pattern? That's my slope. But when we're dealing with equations, we typically think of slope as a fraction. Okay? We call it rise over run. I don't know if that's any easier to read, kinda. Probably not. So we'll just zoom back out. Okay, so here's an example. Y equals -3/4 x plus 4. So we start with that y-intercept. The y-intercept doesn't have a variable with it. If it's next to a variable, it's not a y-intercept. And the y-intercept is always going to be in an ordered pair. It's always going to have 0 on the x, because the y-axis always has a 0 value for x. And then whatever your b is becomes that. In our case, it was positive 4. Okay, so then you plot that point. And I don't know why I all of a sudden turned it into a -4. Apparently I'm going to change. Wow, just barely noticed that. Okay, apparently we decided to make that a plus -4. Okay, so think of it, change this to that, and then everything else will work. Okay, so 0, negative 4, that's where we start. Okay, this is the start from the y-intercept. Once we figure out our slope, we use that starting point and we apply the slope, the pattern, to get to the next place. Okay, so our slope here is a fraction. Okay, negative 3 over 4 tells us where to go. And the way we think of it is rise over run. It's always the vertical over the horizontal. The top number tells us if we go up or down. And if you have a negative fraction, I would always make the top one the negative and leave the bottom positive. The negative, or the top will tell you if you go up or down. Positive, it goes up. Negative, it goes down. The bottom will tell you to go right or left. If the bottom's positive, it goes right. If the bottom's negative, it goes left. Now, when you're dealing with fractions, you will never have a negative 3 over a negative 4, because that's just a positive 3 over positive 4. The negatives cancel out. So you either write it negative 3/4 or 3 negative fourths. Okay? You'll get the same result regardless of which one you do, as long as you follow those directions of the top and the bottom. Okay? So, and here's kind of a rule of thumb. If this slope is positive, my line should look something like this. As I look left to right, it should be going up somehow. Maybe steep, maybe shallow, but it's going to be going up. If my fraction is negative, it's going to be going down like that. Okay? So, negative 3 over 4, I start here at my y-intercept. We count down 3, to the right 4. That's our next point. We can keep that pattern down 3, to the right 4, next point. And we can keep going. Now, because we figured out that pattern, we can also go backwards and go up 3 and to the left 4. And apparently my line wasn't the best at drawing it. Should have been right about there. Okay, up 3 to the right. Okay, that's how you can follow that pattern. My line just wasn't the best. I drew it freehand, so sorry. If you can draw a better line freehand, by all means, come over here and draw it for me. Okay, so that would have been, had I said my fraction was 3 over negative 4, we would have went positive, up 3 to the left 4, up 3 to the left 4. So it's still the same pattern, okay, but that's slope-intercept form. Now, the other type of equation we run into, the main other type, is called standard form, okay, and it's when the x and the y are on the same side and you have a number all by itself, just a constant. So our equation, 7x plus 3y equals 21. Now, the easiest way to go from standard form is to find the x and y intercepts. Now, on both of these, slope-intercept form and standard form, you could draw a table. You could fill out the table like we talked about on the last page, and from there plot the points. That is always an option. Okay, these are just shortcuts. So, you find the x and y intercepts. X-intercept, where does it cross here on the x-axis? Y-intercept, where does it cross here? Because of the nature of an intercept, okay, an x-intercept is always some number, comma, 0. A y-intercept is always 0, comma, some number. So we're going to use that. It's basically like we're making a short table and saying, well, what is x when y is 0, and what is y when x is 0? Okay, that's why this works, and that's why we do this process. So first, make the x equal to 0. Okay, like we're doing right here. If I make the x equal to 0 and solve for y, that's my y-intercept. That's telling me what number goes right there in the question mark, or what number goes right here on the y-axis. Okay, so we solve it out. 7 times 0 is 0, so we get 3y equals 21, divide by 3, and we end up with y equals 7. So its point is 0, 7. That's our y-intercept. So we draw their point. Okay, then we do the same thing for the y value. We make the y value 0. This is going to tell us what goes in this question mark because the y value is 0. So we go 3 times 0. That eliminates. 7x equals 21. Divide by 7. We get x equals 3. its point is 3, 0 on the x-axis because it's the x-intercept. So we plot that point. Then we say, okay, we know where the x-intercept, we know where the y-intercept is. I'm just going to connect those two dots, draw my line, call it good. And that's all we got to do for the standard form. Okay, so there's two ways to go from equations to graphs, and from a table to a graph. But like I said, I think sometimes it's easier to make the table. The table makes it really easy to go to a graph, makes it really easy to go to an equation, which we'll learn later. Just helps out a lot. So there's our frame. Keep this, use it in your homework. Bring it for tests so that you can use it. Bring it to class so we have it there to look at. There we go.